Okay, problem number 1. We're going to add 20 to both sides of the equation and wind up with 3x equals 28. And our final step is going to be to divide both sides by 3 and not get scared when this does not come out to be a whole number, because you could say, how many times does 3 go into 28? And that would be 9 times, getting you up to 27, but we're missing one, and it would be 9 1/3 is your answer. Or you can actually leave your answer as 28/3. Problem number 2. This time we're going to subtract 7 from both sides and carefully get negative 11. And finally, we're going to divide both sides by 2. And there's our answer, negative 11 over 2. But we might be able to reduce this so that it's not an improper fraction. We can make a mixed number. We'll say 2 goes into 11 5 whole times. Still negative, but there's 1 left over. So that's going to be 5.5 negative. Welcome to problem 3. This time we have 4 times p, so we must undo that multiplication by dividing both sides by 4. And we wind up with p equals negative 23 over 4. That's a legitimate answer, but we can make that into a mixed number by saying 4 goes into 23 5 whole times, still negative, but 5 times 4 is only 20, not 23. So we'll have 3 left over with a 4 underneath. Final answer, negative 5 3/4. Alright, problem number 4 has a little bit of a different flavor to it. First, we're going to subtract 1 from both sides. That'll leave us with g over 5 equals 9er. Now, our problem is that our variable that we want to isolate is being divided by 5. So we must undo that division by multiplying by 5 so we can reduce it. To be fair, we multiply the other side by 5, and we're going to be done once we get 45. Problem 5. Uh-oh. 2 variables on the same side of the equation. What do? We do not start subtracting from both sides of the equation yet. Let's clean this up. Since we're on the same side, we can just do what the coefficients say. 4x's and 3x's would be 7x's equals 31. And now we're in familiar territory. Divide both sides by 7. And we wind up with x equals 31 divided by 7. And again, 7 doesn't go in evenly. Let's change that to 7 goes into 31 4 whole times. But 4 times 7 is only 28, leaving us with 3 extras. And there's our answer, 4 3/7. Alright, question number 6. Not too bad. This time we're going to add 9 to both sides. Wind up with 2x equals 20. Aha, this looks nice because when I divide by 2, I will get x equals 10. Question 7. Uh-oh, we're back to 2 situations with variables. But this time they're on opposite sides of the equals. So, we can deal with that by subtracting 4x from both sides, so we can remove it from this right side, reappear it on the left by doing the proper math, which will lead us to 2x equals, what's left over there? 24. And now we're back to good old division by 2. And this time we got lucky. 2 goes into 24 12 times. And we're done. Aha, problem 8 has a little bit of everything. We got variables on different sides. We've got numbers on different sides. Let's do this first. Let's start by adding 10 to both sides. If we do that, it'll disappear from the left side, reappear on the right side once we do the math, which will lead us to 40. Now, we want to move these variables over here by subtracting them. Always do the opposite, to disappear it and reappear it. Now, once we do that math, we'll get 4x equals 40, and we're in the home stretch. Divide by 4, and you wind up with x equals 10. And don't forget, you can check all of your answers by substituting that back into the original equation and see if it comes out to be true. This time, I guarantee it.